Hello guys, welcome to MoBileMaThS with Gumtry. We are looking at Matrices 6. Today we want to solve those practice questions that I gave you in the previous lesson. So here the first question is asking us to find the inverse of this matrix. Okay, so let's find the inverse of that matrix. So the first thing that we do when we want to find the inverse, we said let me write it in terms of A, B, C, D. So this is the same as A, B, C, D. Okay. Now, the first thing that we do, we said we interchange A and D. So if we interchange A and D, we have 7 here and 3 here. Okay. Now we have interchanged. The second thing that we do, we said we multiply B and C with -1. Okay, so if we multiply B and C with -1, these are the numbers that you are multiplying by -1. We are multiplying by -1 here, these ones. Okay, so if we multiply by -1, we will get 7 -5, 4, 3. Okay, so that's now the matrix that we have. Now let's find the determinant of that matrix. So the determinant of the matrix is 1 over AD minus BC. Okay, so if we go back to our question, we have 1 over A. Our A is 3, so it's going to be 3 times 7 minus 4 times 5, like that. Then if we simplify, we get 1 over 21 minus 20, and this is equal to 1 over 41. Okay, because our minus and minus here, we will get a plus. Okay, that's fine. So this becomes our determinant. Now our inverse becomes, our overall inverse becomes inverse becomes 1 over 41, 7 minus 5, 4, 3. Okay, so that's our inverse at the end of the day. Now let's go back to our question. The second question is saying hence find x and y in this matrix. Okay, so the first part is the one that we have got our inverse. Okay, so we are going to use that inverse and find the value of x and y. Let's do that. Okay, now we write our matrix. We have got 3, 5 minus 4, 7, xy is equal to 10, 3. Okay, introducing our inverse, we have 1 over 41 by 7 minus 5, 4, 3. Then we write what we have here. We have 3, 5 minus 4, 7. Then we have x, y. So what we do on the left side, we do on the right side. So we have our inverse 1 over 41, 7 minus 5, 4, 3. This is multiplying with 10 and 3. Okay, like that. So if we are to look at our inverse multiplying its matrix, inverse multiplying its matrix, the result we said we get an identity 1, 0, 0, 1. I will show you before the end of the lesson how we come up with that. So this becomes equal to 1 over 41, 7 minus 5, 4, 3, 10, 3, like that. Okay, so now in identity multiplying any matrix will get, in this case we'll get this matrix. So I'll write x y is equal to 1 over 41 by 7 minus 5, 4, 3, and 10, 3 there. Okay, so now let's solve that matrix that we now have. Okay, let's solve that matrix. Solving our matrix, so I'm now concentrating on the right hand side. So I'll have xy here is equal to 1 over 41. So I'll put my scalar later on. Then multiplying, we said we do the row by column method. Row multiplying by our column. Okay, so let's do that. If we do that, we'll get 7. We'll get 7 by 10 plus 4 by 3, then minus 5 times 10 plus 3 by 3. Okay, so if we do that, let's simplify. What do we get? If we simplify, we will get 1 over 41. Then here we'll get 70 plus 12 minus 50 plus 9. Okay, let's simplify that. So it's still equal to x y on the left side. X y, don't leave that. 1 over 41. 70 plus 12 we get 82. On the bottom we have got minus 41. Okay, now we multiply with our scalar. Let's multiply with our scalar, our 41 there. We want to multiply 41 into our matrix. So we'll get x, y, then is equal to 2 minus 1 if we multiply. So at the end of the day, we said the value of x and y are the ones that are corresponding to each number. Okay, so our x is equals to 2 and our y is equals to minus 1. Okay, so let's do the proof of our identity matrix, our inverse matrix multiplying with its matrix. Okay, so our inverse was 1 over 41 multiplying 7 minus 5, 4, 3. Okay, that was our inverse. This is our inverse, and our matrix was 3, 5 minus 4, 7. Okay, we said this, if we multiply, should give us an identity 1, 0, 0, 1, like this. Let's prove that. We want to prove. So when we are doing that, we said we can multiply row by column. Okay, so let me do that. Row by column, I'll get 1 over 41 by 7 by 3 plus 4 by 5. Okay, so that's for the first column. The first row again, with the second column, I'll get 7 by minus 4 plus 4 by minus 4. Okay, then on the second row, I'll get minus 5 times 3 plus 3 by 5. Then on the second column, I'll get minus 5 times minus 4 plus 3 by 7. Okay, so that's what we have. Let's simplify that and see if we'll get 1, 0, 1, 0. So I have 1 over 41. Simplifying 7 times 3, I get 21 plus 20 there. On the other part, minus 7 times minus 4 plus, I'll get okay, so this was a 7, this one was a 7 there. Let me correct this one. This was a 7 here. Okay, So I'll get 0 this side. Okay, then on the bottom, minus 5 times 3 plus, I'll get is 0. On this one, I'll get 20 plus 21. Okay, so simplifying, I'll get 41, 0, 0, 41. That's the matrix that I have with a scalar of 41. And if we introduce our scalar, multiplying our scalar, we'll get an identity of 1, 0, 0, 1. So that's how we prove. Otherwise, let's do the next question.